everybody for coming back for our second Think Data Thursday. For those of you who are unable to make it last week, I'm Tracy Fitzgerald, the Community Support Engineer, so you'll see me trolling the forums and trying to get the community active. And we also have Dustin Smith on our line. He's our Community Support Manager. He's kind of in charge of anything community. And then today, which I'm assuming a lot of you signed on for, is we have a very special guest, Joe Mako from Rosenblatt Securities, and he's going to present for us. I'm sure you've all seen him all over the forums. He's a longtime user of Tableau since, I think, 2008, and he has extensive knowledge of how our product works. So he knows how to do all the things that Tableau is supposed to do, and then he's really good at finding workarounds for things that Tableau's users might not easily be able to find. So before I turn the floor over to him, I just want to go over really quickly how we're going to communicate through this forum. So first of all, in the chat dialog box, that's kind of the best way that everyone can be heard and participate, because right now you're all on mute. So in the bottom of the chat dialog box, there is a little section that says send to. If you click on that and I'll scroll all the way down and click all attendees, then when you chat, the whole group will be able to see it. I believe you should all be able to see everyone who is in the attendee list at this time. If you can't, let me know, and we'll just do it kind of how we did it last week, where you can just shout out in the chat, and then we'll be able to see who's online. And then, so like I said, you're all on mute. So if you have a question or you want to say something out loud, there's a little icon, where is it, where you can raise your hand. So that will notify me or Dustin, and we'll be able to unmute you and then kind of call on you in a sense. And then you'll be able to speak for everyone to hear, 'cause sometimes that's easier than just chatting away. So, so with that, I'm going to make Joe our presenter, and he'll present away. Thank you, Joe.
All right. Well, thank you everyone for joining us here today. Nice to be able to speak to you. I'm going to go ahead and share my desktop and dive right into this. I'm going to cover a lot of ground here today. I'm going to talk about my philosophy on how I approach table calculations so that you can better use them in your own practice, and so that you can be aware of the factors that are affecting table calcs. So when it comes time that it's not producing the results that you want, you've got a set of troubleshooting steps to take a look at, or things to consider or backtrack so that you can get the result that you're looking for. Okay? So one of the main things with all things in Tableau is going to be your pill types. And there are really four main pill types. You've got your continuous dimensions, your discrete dimensions, your continuous aggregates, and your discrete aggregates. Generally, when you think of pills inside a Tableau, they're going to be your discrete dimensions or your continuous aggregates. All right, just to show you a quick example of that. When you bring out a dimension pill, normally it's going to come out as a discrete dimension. When you bring out a measure pill, it's generally going to come out as a continuous aggregate. Okay, so your aggregations are summing up a whole bunch of smaller records to produce a single value. All right, so this profit here is a whole bunch of individual records that are getting summed up to produce that single profit value. All right, whereas this subcategory, this is all the distinct values that exist inside the data source for this field. And so your dimensions are going to set your level of detail, and then your aggregations are going to be summing up or averaging or performing some aggregation of values to that level of detail. And this awareness of your difference between your dimensions and your aggregates is a key thing in being able to use Tableau effectively and producing the results that you're looking for. Okay? So it's common to see these blue versus green, and that's going to be the easy differentiation. And that's just going to tell you whether it's continuous or discrete. And continuous or discrete does not have any impact on the computation. Continuous versus discrete only affects the display of the numbers and the values and what dialog boxes you get. So this profit value here, I can switch it between continuous and discrete, and it's still going to be that single number. It's just either going to create cells and panes as a blue pill, or as a green pill, it's going to create an axis on the columns and rows shelf. If I move it to the color shelf, I get a color dialog that's going to be a gradient, versus if I have a blue pill on the color shelf, I get discrete colors. Same thing on the filter shelf. For the blue pills, I get check boxes, and for the green pills, I get more of a continuous selector of at least or at most. So yes, blue versus green is important for your visual display, but it doesn't impact your computation, and blue versus green is not important for your table calculations. For table calculations, what matters is the pill a dimension or is it an aggregate? Is it an aggregate or is it a non-aggregate? Okay? So any questions as far as determining the difference between your types of pills? Don't know if I can bring up questions or whatnot, but just wanted to check in to see if that's good or if I should continue moving on.
It doesn't look like there are any questions
Okay.
right now.
So I'll go ahead and move on. So VizQL, this is what makes Tableau Tableau, in my opinion. That this is why I love to use Tableau, is because of the VizQL programming language. Every time that we are dropping pills on shelves and configuring those pills, we are authoring VizQL. Now inside of Tableau, what we can see really is just this pills on shelves and the final view that it produces. These other 4 steps, Tableau is taking care of in the background for us. Tableau is doing all that heavy lifting for us. But I feel that if you want to really take advantage of table calculations, you have to understand what's going on behind the scenes in order to effectively use it. So where VizQL is very powerful in letting us do just some simple drags and drops, and it produces amazing output. If you want to really have control over that, it takes a greater level of knowledge of what's going on behind the curtain. All right, so just to run through this really quick, when you place pills on shelves, that's you authoring VizQL. That VizQL will generate query, whether it be SQL or whatever, to talk to your data source, and then your data source will interpret that query and provide query results. These query results are what Tableau can deal with. This is what Tableau has at its disposal. So anything that happens with Tableau is happening off of these query results. Now sometimes these will be separate queries if you're dealing with filters and other things like that. But generally your view is based off of a single query. And that single query results, then Tableau will apply manipulation to it, whether it'll duplicate the data, it'll perform calculations, it'll reshape it, it'll do stuff to it in order to produce the final view that you've asked it to do from your pills. So your table calculations are going to happen inside of this interpreter step. And this interpreter can see these query results. So really, if the data doesn't exist inside your query results and the interpreter can't create it based on the query results, then your table calculation has no capability to do it. And this comes back to the idea of if you can manipulate your data prior to Tableau, you can have Tableau produce anything you want, that there is no limits. But what Tableau is bounded by is your data structure and your data source. So if you can manipulate your data source prior to Tableau, you have no limits. But if your data structure does determine your boundaries of what you can and can't do. All right, so let's dive into a couple of table calculations and how this works with Tableau. All right, so looking at this view here, what we're asking to do is what we're going to take a look at is the difference between a window and a total table calculation. All right, and these two reference lines are kind of our simulation of our table calculations because they work very similarly in my experience. All right, so let's start this off with a new worksheet. We'll bring out our container and sales. And if we look at our average sales for each one of these and sort it descending, and an interesting question would be are these average sales for each container above our overall average sales? The initial thing that would commonly happen is you'd add a reference line and say, I want to look at the average of my average sales and draw a line for me. And it looks like I've got my average sales and I can see that these 3 are above and these 4 are below. But this average is an odd thing. This average reference line is an average of an average. This is an aggregate of an aggregate. And that's the same thing that your window calculations and your running calculations are going to do. They're going to take an aggregate of an aggregate. This is an aggregate on top of your query results. So it's kind of like a query of a query that Tableau is doing to produce this reference line. Where what we really want to take a look at is what is the overall average? What's the average sales irregardless of our container? And one way that we can see that is by turning on our column grand totals, and we see our total average. This is our average if we remove the container pill from here. So we can see that an aggregate of an aggregate is not always the same as an aggregate at a different level. So if I remove container from here, our average sales is that 1776. But with container out here, the average of the average is 2691. So the way that we can get access to this average at a different level is with the total calculation. And we can also add a reference line to compute that visually as well. So this total is not an aggregate of an aggregate per se, it's more like an aggregate at a different level. So when we add this out there, we can see that our total reference line matches up with our grand total. And now what we can see is that 4 of our containers are above average, versus before we saw 3 were above average. So this awareness of how the computation is happening is very important for aligning your business logic up with what results are produced and how your computations happen. Okay? So an easy way to show this to you is to color these bars differently based on where they're at. So first we'll do the window average. So we can say if our table calculation window average of our average of sales is, let's say our average of sales would be better here, is greater than our window average, then we're going to be above. Else, we're below. All right. So I can go ahead and just put this above down here on a new line, make it look a little bit nicer. And there we go, something like that. So this is going to compare our average sales, which is being produced by this pill. So we can see our jumbo drum has got this average sales way up here. And then this window average of our average of sales is the same thing as this reference line here. Now when we write out the calculation, we can see that this is an aggregate of an aggregate, and the fact that we wrote average out here 3 times. We could also change this to be a sum of an average or any other type of combination of aggregations that we want. So an aggregate of an aggregate, we've got it written out there twice. All right. And so with this calculation, we can put it on our color shelf and see the ones that are above or below. To change this to work the same way as the total, we could put another if line in here that says if our average of sales is greater than our total average of sales, then we'll do the same thing. So you can comment out these lines to see how they work differently. Call this above and below. Above or below. And what did I do here? If. So this comparison is going to look at to this total reference line. And we can see now that it's colored based off of that computation now. So that's going to be your difference between your window calculations and your total calculations. The total will be like going back to the data source and computing that aggregation at a different level, whereas your windows and your runnings are going to be an average of an average or an aggregate of an aggregate. All right. The next type of table calculation to look at is going to be our ordinals. And these ordinals are important for understanding how do we work with something within inside of our window. Okay? So most of us have used the index function. It just does a count of the marks within inside of a partition. So in this case, we get a 1 through 7 here. The first calculation and the last calculation are very similar to this index function. But what they tell us is what is our distance from the first mark or the last mark in the partition. So for jumbo box, its index number 1, its distance from the first mark is 0. And the jumbo drum, it is the second in the partition, so it is -1 to reach the first. So we would take 2, subtract 1, that equals 1. Same thing with all these other ones down here. For small pack, its index is 6. We'd have to go back 5 marks to reach the first mark. All right, and it's the same thing for last, except in a different direction. For these, it's the distance from the last mark. So we'd have to add 4 to go from 3 to 7. And that's how it's number 4 there. And then size is going to be what are the number of marks inside this partition. All right. So those are another important thing to have awareness of and how they work and where these numbers are coming from. So why is this useful to be aware of this? Well, we use these to deal with either offsets or other interesting ways to use them. So if you want to do like a percent difference from previous or do a percent difference from first, you're using these offsets. Okay? So if we take a quick look at our window and running, they're very similar to each other. And in fact, you can make your windows do the same thing as a running. So if we look at our running sum of sales, it's a running sum of the sum of sales, an aggregate of an aggregate. It's taking each one of these sales and adding them to each other, or taking a running sum of them. So this first one is the same as the first. This next one takes the 332 and adds that to the 516 to get us the 848. Okay? And so it's doing a running sum. Whereas this window running sum, this is going to take the window sum of the sum of sales, and we're going to go from the first to the current. This is where we get into those offset dealings there of this first calculation is going to be a different result for each mark in the partition. So for the first mark, the value of first is going to be 0. So we're going to take the window sum of the sum of sales going from 0 to 0, or going from the first mark to the first mark. Then for the second mark, first will be -1. And so that means it's going to take a distance of going back 1 mark to the current mark. All right? And that effectively gets you the same thing as the running sum of sales, or the running sum table calculation, just a different route to arrive there by using the offset and the first and last arguments of the window sum calculation. All right? And then your lookups also are going to use these offsets. And this is where we can do, let's say, a lookup of our first sum of sales. So here we've got our sum of sales for each container. We can do a lookup first and get that first value and make that available to every mark in the partition. And similarly for our next, with this one, it says an offset of 1. So this just advances 1 or looks at the next mark in the partition and returns that value. And same thing with previous. This one goes back 1. It says an offset of 1, look up the sum of sales for the previous mark. Okay? And then previous value, this is a really interesting calculation. This is a self-referencing one. What this calculation says is take the result of the formula that I'm a part of and substitute it in. It's kind of like a recursion, but I call it a self-referencing calculation. For example, if we wanted to recreate the index function here with previous, we just take the previous value, starting at 0 when there is no previous value, and add 1 each time. So what this is saying is for the first mark in the partition, there is no previous value, so I substitute in 0. Then I add 1. Then for the next mark in the partition, the previous value was 1, so I substitute 1 in for this, and I add 1 to get a result of 2, and so on and so forth, that we're just adding something to the previous value. So with previous value, we can have a custom index. Instead of incrementing it by 1 each time, we can increment our index by 2 each time. All right, so just a different way to customize it there. And also, the previous value can also replicate the running sum as well, where it takes the previous running sum value and adds the current value to produce our current running sum. This is very similar to something like in Excel, where if we said, some random values here, oops, if I could type in some numbers, and we said equals our previous value plus this value. And let's turn this down just a little bit. So this Excel calculation, where we're taking the previous value in this column or inside of this field and adding another value to it. It's taking our running sum. It's very similar to what's going on here inside of this calculation. Okay? So, with all of that awareness of these different calculations, there are nearly an infinite ways to combine them in all sorts of useful ways. But there's all sorts of pitfalls inside a Tableau, that there's invisible things that when you try to do something, it doesn't work the way you want it to. So let's look at an example of that. So if we created a container on our row shelf and looked at our sum of sales as a stacked bar with a bar segment for each category, we get a nice looking view like this. If we wanted to add a rank number here or some type of filter to say I just want to keep the top 3 or anything of that nature, we would think I can just use index on this. Just a simple index table calc and turn that into a discrete, and let's see here, discrete, and pull it out here. We would think we just get a simple 1 through 7, but instead we get this craziness, 1 through 7 with both large box and jumbo box being treated as number 3. This isn't working as expected. And this is something that a lot of people run into problems with on the form and with Tableau, is with calculations that don't work as we expect them. And the reason why they don't work as we expect them is because of awareness of how Tableau is computing this. So why is Tableau doing this strange numbering here? It's doing that because not all combination of our dimensions exist. And this is why it's vitally important to be aware of what are your dimension pills when you're dealing with table calculations, because your table calculations are based on your dimension pills. When you select your compute using, you're telling Tableau what to use for addressing, and all other dimension pills will be used for partitioning. And then, based on your arrangement of these pills on the worksheet, or how the sorting is set up, will determine how Tableau can compute this. So if we have both of these on the row shelf, like this, we can easily get our index to compute correctly, where we will get our 1 through 6 if we say compute using container here. Or is that correct? Nope, we won't still. So this is still going to be an error, and we still get these strange results, because what we've got going on here is the sorting is happening differently than how the computation is happening. And we can get closer to the result we're looking for by using an advanced compute using. And when we use an advanced compute using, what we're saying is create a set of these two dimensions and then sort that set, sort each one of those distinct set values by what we select here. If we say sort descending, and what we can get off of this is get each of these values sorted. So each distinct mark is sorted descending based on our sum. If we come into here and say, I want to restart each container, effectively partitioning on our container, we get a 1, 2, 3 for each one of our category values. So in order to select container, or rather category, as a restarting every inside of here, we would need to adjust the arrangement of this and put category at the top. And now we can restart each category. And still, it doesn't look quite right. So really, the user interface that Tableau provides doesn't allow us to get the result that we're looking for. If we want to get this result here with missing a combination of our dimension, where we have a gap in our data, the only way to consistently do this is by using a combination of table calculations inside of a calculated field. So by looking at our container and category out here, and we sort our container descending on sales, we get them sorted correctly. Now, if I bring out another calculated field here, this time what I'll say is, does the previous container equal the current container? So what I want to detect inside of this calculation is, when do I change this visual pane? So I could say, if the ATTR of container equals the lookup of the ATTR of container in the previous mark, then I want to return my same value. So I could say previous value. Else, if it doesn't match, if we have changed our pane, what I want to do is previous value and add 1. So what's going on here is we've recreated our own custom index and built in the incrementing inside of the formula. So we will only increment our index or our counting when we change to a new container. All right. So with this calculation out here and set to table down, we get our correct numbers 1, 2, 3, 4 all the way down. And if we turn it into a discrete, we can put it out here on a display, and it looks great. And you would think that, okay, this is the end of it, we're ready to go, we can rearrange our pills. But once you put category out here, everything gets messed up again. Because Tableau is based on what pills are on what shelves. And currently, there's no user interface to define this compute using setting where we're based on the sort of container and ignoring category. The only way to get this result is by using the compute using table down. Now what's really nice about Tableau is this show me button. And if you can get the computation that you want, you can use the show me button to lock that computation in. So if I use the show me button here with the sales out here and stacked mark, Tableau has locked that computation in. And now I can rearrange these pills to whatever arrangement I want, and the computation stays working correctly. Versus if I don't use the show me button and rearrange the pills, when using things like table down and pane down, the computation will change. Okay? So then to get our final detail, we can shift up the borders and we get a nice final result. Okay? So in my opinion, with that understanding and the ability to create this view and understand all the constraints that are inside of this, you're working with multiple table calculations. You've got awareness of your pills. You've got awareness that the show me locks it in. You've got awareness that your dimension combinations can potentially affect your computations and produce some unexpected results. The awareness of this I would consider to be the basic or competent use of table calculations. And I know it's quite a lot to cover up in a quick half hour, so that's why I want to leave the rest of this time here for Q&A, or if you can think up interesting situations, we can solve them live here for the next half hour or 45 minutes or however long we have, and we can address your real-world situations. But this covers a lot of the key factors, and there are dozens of more factors that affect table calculations as well. That really, when I'm doing table calculations, I'm having to hold all of these different factors and different awareness in my head because there's all sorts of pitfalls with them. All right. So hopefully that gives you a good introduction to table calcs.
Joe, I think that Tim would like to see calculation 1 again. I don't think he got a good look at it.
All right. I want to run through this again. So the way to look at this is best inside of the view previous here, where we've got our container and category out here. And we can put sales out there, format, borders, clear that back out. And with calculation 1 as a discrete out here. All right, so what this is doing is our partition that we have set up is table down. It says table across there, but really it's going to be table down. So our compute using is table down. We are not partitioning on anything because all of our dimension pills exist on the rows shelf. So our compute using is visually down this table. And so what we're saying is that all of these marks are inside of that same partition. All of these marks are inside of that same bucket, and they are sorted. Each one of these marks has a sorting to it, and that sort is coming from our arrangement of our pills, and we have a sort on container. So small box furniture is our first mark in our partition, small box office supplies is our second, small box technology is our third, jumbo drum furniture is our fourth, so on and so forth all the way down. Then inside of this calculation, I'm using a lookup and a previous value. Both of these calculations are what I consider to be reference table calculations. And for reference table calculations, the sort order of your addressing or your compute using within inside of your partitioning is very important because it's what that's going to use. The lookup is going to look up based off of an offset, in this case a -1. I'm going to look to the previous mark and see what is the value in the container field. Whereas previous value, I'm going to say, look at this calculation's result for the previous mark and substitute it in. So by looking at our container for our current mark and comparing it to the container for our previous mark, is the container the same? If it is the same, return the same value. If it's different, if it is not equal, then we're going to increment it by 1. So going down this list, every time this pane changes, we're going to increment our value or increment the result of this calculation by 1. Does that make more sense? Or what are the questions about that? Okay, looks like you got it. All right, so that is really my classical table calculation example. And there's all sorts of other things that you can do with table calculations. Let's see here. Don't know if anybody's got a question or anything on the Tableau form that they saw that they'd like to see run through, or if you want me to come up with another real-world example, I could show you another interesting way to use table calcs.
It looks like we have a question from Jonathan. His question is, what are conditions under which we'd expect the show me to be useful in setting the table calculation?
The show me does not set your table calculations. What the show me does is it locks in your current settings and allows you to move your pills around. So the show me is one step in the process to get the end result that you're looking for. So the show me is not setting anything. The show me is locking in your current settings. And sometimes your arrangement of pills, you can't use the Tableau user interface to get those results, which we showed here earlier. In order to keep this computation of 1 through 7 and get a visual arrangement that looks like this, the only way to get that result that we want is by first getting our computation working correctly in this type of view and then using the show me to lock it in. Let's see what this says. Using the ATTR can be really useful. Is there another example of its use case? All right. Well, really, the ATTR function is a shortcut and something that makes it easier to understand what Tableau is doing, where really the ATTR function, if I were to rewrite it, so the ATTR is equal to saying if the min equals the max, then give me that value, else give me an asterisk, an end. So the ATTR function is saying with inside of this mark, is the max value with inside of this mark of all those underlying records equal to the max value of all those underlying records with inside of that mark? And if the max is equal to the min, then we'll return that value. Otherwise, we'll return an asterisk. So ATTR is more of a shortcut or a conceptual, easier thing to understand, whereas you could substitute ATTR with min in many cases, and you could argue that maybe it's a little bit more efficient to use min instead of ATTR inside of this calculation, but with this amount of data, it doesn't have much of an impact. Okay. What else did we have for a question here? Can you show us what happens when you don't use the show me? Yes. So if we don't use the show me button, we change the computation. Where right now Jumbo Box Furniture and Jumbo Box Technology is both under a result of 3. If I don't use that, then Jumbo Box gets a number 3 here, and let's see, Large Box gets a number 3, and Large Box gets a number 4. So we get a different computation because we moved our pills. And a table down and pane down, these are very sensitive setups. They are sensitive based on your arrangement of pills. So if you change your arrangement of pills while using a table down or a pane down or a cell, your computation can change. So generally, I don't recommend using the table down or pane down. I would recommend specifying it exactly to what you want to use. But this is a situation, in this case, where you can't use the built-in Tableau user interface to get the computation, that the only option is to use a table down. And I saw another question. To add to your expression extensively when I have to change the title of a sheet dynamically based on my selection. Yes. So ATTR can help with that in dealing with how Tableau handles a repeating value and being able to use that in a title versus a inside of the worksheet itself. Sometimes Tableau will substitute in the word all or substitute in that exact value, depending on how you have your filters set up. It's one of those slight details. What's this? If ATTR equals max, then ATTR else all. Yeah, I suppose you could do that. That would be basically the same thing as saying min equals max, then min, else all. So yeah, there's many different routes to get to the same results inside of Tableau. And, we could sit here and discuss what are the benefits or the detractors to each one of these different routes, or what are the situations where one route is better than another route. There's all sorts of factors that affect the performance or the computation to figure out what's going to be the best route to get to the end result that you want. But with Tableau, there are definitely multiple ways to get there.
I think that Alex Blakemore has a question.
Did I see it? Did I miss it?
I think you raised an answer. You're off mute, Alex, if you want to talk out loud.
Yeah, I was just asking, I've been looking through your horizon graph demo you put up, which was, a real nice piece of work, and didn't quite follow everything about it, and haven't had, just wondered if you had that nearby and wanted to walk through it, or
Sure.
whether that would take too long.
We can deal with that.
And then, yeah, so I saw you were using total in there, so I guess what, so it's total's doing, I guess, was kind of throwing away the categories that, calculating the unemployment rate regardless of the state. Is that?
Yes.
So
it's calculating the total overall unemployment rate irregardless of the state. So I'm not taking an average of each state's unemployment rate. I'm taking the
You're getting the
total
national.
average. You could almost call it like a weighted average is what I'm doing with
Okay.
the total. In
Yeah.
fact, I think that's exactly what Tableau does in the background. If you initially start off saying, I want the sum of, or the average of sales, and then you turn on grand totals or subtotals or use the total table calc, what Tableau will do is instead of issuing another query, it will issue additional aggregations. It'll send a count and a sum of sales in order for Tableau to compute that total average at any level you want. So it's an example of stuff happening inside of the interpreter. All right, so if I download this workbook, we can take a look at this. Open this up and see what we've got going on inside of here. Now, this workbook was more of an example of what is the most that I can throw at Tableau Public at once, where I'm doing a lot of computations. Whereas if I were to do this in reality, I would do some of these computations prior to Tableau, because just Tableau table calculations take too long to compute these things. So it's more of just a demonstration of what's possible. If we look at this data, what I have it by is each month for each state, I have a single record. All right. This is generally my first step when I deal with any data source, is I want to know what combination of dimensions creates a single record. So in this case, it's the combination of month and state that makes a single record. Then at each one of these records, what I have is the sum of labor force and the sum of employment and the number unemployed for each one of these values here, each one of these dimension combinations. And so with this, I can calculate an unemployment rate. If I look at this, I'm calculating the sum of unemployment divided by the sum of labor force. Now, what you may be interested to know is, why am I doing the sum divided by another sum instead of just simply dividing the two? So with this unemployment rate, it gives me the correct unemployment rate at any level. So if I simply did, let's see here, what was it? Unemployment divided by labor force, divided by labor force. This one, it looks like it would do the same thing. And if I turn it into a percentage real quick, we can see that it does indeed give us the same number when we're dealing with each mark representing an individual record in the data source. But when I change my level of detail to something like month, now they're different computations, because this aggregation versus this calculation here are happening at different levels. This division is happening at each individual record, and then they're being summed up. So it's essentially like saying, take the unemployment divided by the labor force at each record, and then add up all of those ratios together. And that's why we get this really strange 400% value there. Versus what we really want is to sum these numbers before our division. So that's the first thing that's going on here in computing this unemployment rate and getting it to work correctly at any level. So you mentioned the total. So let's see here. We've got our unemployment rate for each individual state. And then we want to compare that state's unemployment rate to the total unemployment rate for that month. So it's going to be this 8% for our total versus each one of these individual states. So how do I bring out this 8% to each one of these? And I do that with a total unemployment rate. And that's going to be our total table calculation. And we know our total is saying compute this aggregation at a different level. So total unemployment out here is going to give me that 8% when I set my compute using to be state. And now we have our 8% there which we saw was the same thing when we removed state from here. And now I can compare these two values to each other. Now, why is it that I selected compute using state instead of compute using month? Well, for total, whatever you select for your compute using, and you can use the advanced table calculation dialog here to put over multiple dimensions, is I'm saying ignore that level of detail when computing the total and just bucket it by each month. So it's taking all of these records that exist inside of each month and giving me the total average or the total unemployment rate. And so I think of the compute using or addressing for the total table calc as ignore this dimension. Just like if you have your state out here and you bring out your total labor force as a number and turn on totals, show column grand totals, this grand total is ignoring the discrete pills on the row shelf. And total works very similar to that, where it's ignoring that state pill. So it's kind of like taking month out here on the row shelf as a discrete and saying, give me a subtotal for each month. And so this total here is the same thing as what we were doing before. So I can take total unemployment rate or unemployment rate and put it out there, and we'll get the similar kind of thing. Let's scroll down just a little bit. We'll see our 8% there. And so I'm repeating that 8% to every mark inside of that partition. And the partitioning is happening on month because I selected state as my compute using. All right, so that's the first step in computing things there. Then everything else after that gets sufficiently more complex, which I don't know if we'll have time to get into today. But that's that example again. Does that answer your question?
Yeah, that's pretty helpful. The compute using was the thing that seemed a mystery to me is how did total know, for example, to ignore state but pay attention to month, and you explained that. So thanks.
Yep. Perfect.
Is there? I'm not asking you to go through the whole workbook, but is there any 30-second tip you can make for like how to understand the next tab?
Okay. So let's see here. Base values. Let's see if we run through this. So the base values is comparing each state's unemployment rate to the total unemployment rate.
Yeah.
So we see those two lines, which we just went over how that was generated.
Yeah, that makes sense.
The next thing that I want to look at is what is the difference between those two lines. So this difference overlay is taking the difference between those two values. So I kind of skipped a step here. If I duplicate this sheet and now say my difference from average, you can pull that out. This difference from average is going to be the difference between those two values.
Okay.
So when the orange line is above the blue line, the green line will be in the positive.
Okay.
Let me pull it out this way as a bar chart. It may be easier to see. And multiple mark types, and say difference of an average as a bar. And that should be set up with its compute using already. Yep, good. So this is positive when the orange is above, and the orange represents our state's unemployment rate. So this is saying their unemployment rate is above the national unemployment rate that month.
Got it.
Versus down here, their unemployment rate is below the national unemployment rate. Orange is below the green. So this is the value that I want to chart, this difference from total. So this next chart is a line for each one of those overlaid on top of each other. And then this coloring is going to be how do I want to shift this? Because for the horizon chart, what it does is it slices those values and kind of collapses them, lowers them, turns them into levels, and then layers those levels on top of each other. So this shift calculation is determining what level are we at. So shift is going to say difference from average and bin it into every 2%, and if it's less than 0, then it's going to be in the negative bins. So this calculation here of shift is very similar to saying, give me a bin of this. You know, if you've ever created bins on something, and I'm going to say the size of my bin is 0.02, that's essentially what this shift calculation is saying, is bin it to every 2%, and then give me a number for that to tell me, is it one above, is it one below, or whatnot.
Okay.
Does that make sense?
Yeah, that helps a lot.
Okay. Then what we do is we draw a line for each one of those. So each shift is going to get its own line. So instead of having the shift calculation out here, I have a calculation for every shift value that I'm going to apply. And what this does is we can see each of those lines overlaid on top of each other. And you kind of have to imagine yourself putting some blinders on here to say, I'm just going to be looking at the axis from 0 to 0.02 or something like this. Let's see here. Is that going to make sense? Maybe. Let's see what that does. Been a long time since I've done this, so no, that doesn't work right. But this is all of these values, charting them out, shifted. So let's see, if we look at Nevada here, let's see if we can figure out what's going on with Nevada here. Is that the same sort order that we had back here? West Virginia state sorted on unemployment rate average. So state sorted on unemployment average. Average, so I'll change this to be on average. Show perimeter control, it's already out there, average. All right, so West Virginia. So for West Virginia, at first.
Joe?
Yep.
I have to get off.
Okay.
But thank you very much.
Okay.
That helps a whole lot. See you at the conference.
Okay. Same to you.
All right. Bye-bye.
All right. So Tim would like me to continue. All right. So by looking at this and comparing it to what we have back here at base values, or this sheet here, is I'm charting this green thing. Let me take this green thing and make it super thin, so it's a little bit better. So we can see that down here we're below. So on this raw line chart, we get the blue, and the blue means that we're in the -1 below, so we can see it right there. Then the orange turns on when we go above. So back here, we turn on and we're going above. Then when our above gets more than 2% above, then we get to see the next line shows into view. So let me see if I can turn on this so that that filters out correctly. Yeah, edit axis and fixed from this from 0 to 0.02. It should be what I want to display there. Or am I saying to 1? Yeah. So there we go. There it is better. That's what I had done there to it. So we get the blue when it's less than the 0.02 below. So right there, it's just less than that. And then we get this one when it goes above, and then the next line comes into view, and then the next line comes into view. So all of these lines are shifted. They're all stacked on top of each other. So instead of them going higher and higher, I've collapsed each one of these layers onto itself. And that's what's going on here with this. Then inside the final view, it is that previous view turned into an area chart and then sized accordingly. So now instead of it being separate lines, it's areas that are overlaid on top of each other. And as far as how does that computation work, inside of here it's saying, am I above, then show me that value, and then divide it by my band size to kind of put them all on that one line. So may not have been necessary to do this band size. This shift may have not been necessary. This absolute value may not have been necessary. So back when I made this, I just made it overly complex than I should have. It can be simplified nowadays. So this difference from average greater than 0, then give me the difference from average. I'd have to adjust all of these to fix them correctly. But that's what's going on there, is it's computing it multiple times, overlaying it, and shifting it. All sorts of interesting stuff. Really, the sky's the limit with Tableau. If you can dream it, you can do it. Really, your only limits in Tableau are your data structure. You can build network node maps inside of Tableau if you can manipulate your data prior to Tableau. You can create tree maps inside of Tableau. You can create just about anything you can imagine. You know, Tableau is like Adobe Illustrator data-driven. You can draw anything you can imagine.
Awesome. Thank you so much for sharing all of this, Joe.
My pleasure.
I think everybody got a lot out of it. You started with the basics and built up really nicely. I think we have a couple requests. If maybe you can send me this workbook and PowerPoint, and then we can post it on the forums for everyone to see.
Absolutely.
That's good with you.
Yep.
So it kind of seems like everyone's kind of towards the end of their day, so I think we'll wrap it up. But again, I can't thank you enough, and we'll post another posting for probably the next 2 weeks for our next Data Thursday. And yeah, so thank you everyone for coming.
Oh, I also wanted to see if anybody wanted to take a survey here to let me know how I did. What could I have done better here? So I'll send that out to everyone in the chat room. So if you guys want to take that survey for me, I'll send that data over to Tracy so that she can have it as well. But I just made up a little quick survey to get feedback on what you guys thought. Okay?
Awesome. Thank you, everybody.
Thank you.
Bye-bye.